Hello children, good morning. How are you all? I hope you are doing well. And today we'll continue the topic called force. In the last class we have learned about the types of forces, mainly contact force and non-contact force, and we have seen the examples of contact force and non-contact forces. And today we will learn about a net force, isn't it? Net force. Say for example, I think in your house you have rubber bands with you. Take one rubber band and with your two fingers try to stretch it. Easily you can do that. And add one more rubber band. That means with the help of two rubber bands try to stretch your two fingers. Now in this case you have to apply more force, and third, fourth, fifth, like that. If you are going on adding the number of rubber bands, then the force you have to apply more. That means basing on this example we are going to extract the topic called net force. So assume that here it is a body and this arrow is nothing but the force which we are applying, or in other words it is called as applied force. We have learned already that there is another force that is called as friction force, which always opposes this body, isn't it? So this is a friction force which is opposite to the applied force. And next, this is T, stands for what? Tension force, and this is N, stands for normal force, and this is tension force. So here on a particular body, for example, if it is placing on a floor, on a table, then many factors or many forces which acts on this body. For example, if a monkey is hanging on a branch, for example, if it is holding a branch of a tree, then how many types of forces acts on that monkey? Easily. Now see, with the help of that monkey's hand, it is holding a branch. That means what? It is a tension force which is acting in a upward direction. And there is another force which acts always, that is gravitational force, which always pulls the body towards to the ground, which is exactly opposite to the normal force. If there is normal force, there is no normal force, then immediately due to the gravitational force all the bodies will fall on it. That's what we have learned. Now coming to how many forces are acting here? 1, 2, 3, 4 and 5. That means there are n number of forces. N number of, that means 1, 2, 3, 4 like that. You know, the multiple forces, if they are acting on a body, then the definition comes like this: the algebraic sum of all the forces which acts on a body, then that force is called as net force. What is that? Net force. Simple definition is sum of all forces. Sum of all forces which acts on a body is called as a net force. Say net force, say assume that this is capital F and sum of all forces. For example, on a body there is applied force F1 and there is another force, that is friction force, called as F2. Now what is the net force acting on this body? We knew that already. I've given you one example in the last class, that if one is pushing the table in one direction and the other one is pushing the same table in opposite direction, that is towards to you, then what happens to the table? Whether will it move? No. So it remains constant. That means what? Say here, take the same example. Assume that this is a table and you are applying with the force of F1 and the other person is pushing the same table with another force. That means he is resisting your force, isn't it? Resisting your force. What is the net force acting on this body? So F is equals to sum of all the forces, no? So F1 plus F2. But thing is, you have to remember here, this force is acting opposite to the F1, isn't it? When the opposing force is there, then you have to write a symbol called minus. You know, as you are the mathematical students, plus into minus, what it will become? F1 minus F2. For example, F1, assume that this is 5, and F2, it is to be assumed that 3. Now what is the net force? So F1 is 5 and F2 is 3. So 5 minus 3, that is 2. So F is equals to 2. But what are the units? In the last class we have learned that the force is a measurable quantity. Force is a measurable quantity. It has both magnitude as well as direction. So in what units this force is measured? That is, force is measured in newtons. We have learned in last class. Newton, see here we are using an alphabet called N. N stands for here newtons. That means the force is measured in newtons. So how many newtons of net force we got from this example? That is 2. So here also 5N, 3N. From here now onwards, here N stands for, remember that, Newton. So the force is measured in Newton. Is it clear? So net force is nothing but algebraic sum of all the forces which acts on a body is called as net force, and the formula is F is equals to F1 plus F2. You may get a doubt here. Sir, in this example there are 4 to 5 forces are there, but you have given the formula as F1 and F2 only. Why, sir? Because from the second example there are only 2 forces. That's why I took 2 forces. For example, if n number of say 3-4 forces are there, then what you have to? The formula will be like this. Capital F is equals to F1 plus F2 plus F3 and so on. Whenever the opposing force is there, then immediately it will become minus. If all the forces are acting in a same direction, then it will become only plus symbol only. Remember this concept. Is it okay? So basing on this concept of the formula, we are going to solve few problems. Okay? So let us see those problems first. So solving these problems definitely will come in the examination, and it is an important question. So first example I am taking. So there is a body and there is a force F1 and which is having 8 newtons. That means somebody is pushing this body with 8 newtons of force. So the other one is pushing with 10 newtons of force. Assume that this is F2. So what is the net force acting on this body? So net force F is equals to F1 plus F2 according to our formula, isn't it? So F1 is what? How much it is? 8 newtons plus F2 is equals to how much? 10 newtons, but with minus sign. Why minus sign? Yes, it is an opposing force, that's why we are keeping minus. Now you know, again remove the brackets. So 8 plus into minus, minus 10. So what is the value? 2 with a negative sign, and the units are N and capital F. So capital F is equals to net force, whereas 2 is a numerical value that is showing about the magnitude of the net force, and N stands for the Newton. Newton is nothing but the unit of the net force. So what about this minus sign, sir? What it indicates? That means the minus sign indicates it is showing the direction of the body to which it is moving. Say here in this example, according to this example and this value, see one person is pushing the body with 8 newtons of force, which is lesser than 10 newtons. So immediately what happens? The other person is pushing the same body with 10 newtons. That means he is pushing the body with 2 newtons of force, which is greater than 8 newtons. So immediately what happens to the body? Yes, the body will move in opposite direction to the F1. So whenever it is in opposite direction, then the value will become minus. The minus sign indicates the direction of, or in other words, it is showing the opposite sign to the applied force. Is it clear? So I will give you example problems where you can solve at your home and try to post it in the group. So the first example is, here it is 8 newtons and another body also moving or pushing. This is 6 newtons. Is it okay? So now from downwards there is another force which is acting on the same body, that is 15 newtons. Solve this problem by using the same formula, and try to get the number and in which direction the body is moving with what type of net force. Okay, have to find out the magnitude. And third example, another body, 1 Newton, 2 Newtons, and here 3 Newtons. Now tell me, I hope, see here two forces are acting in a same direction. That means what? 1 Newton plus 2 Newtons. That means 3 Newtons. But in the last case, see, on other side, the other person is pushing the same body with 3 Newtons. So 3 and 3. As you know, I will explain. See, F is equals to F1 plus F2 plus F3. Why F3, sir? Because there are 3 F are there. That means 3 types of forces. F1, and this is F2, and this is F3. So F1 is equals to 1. F2 is equals to 2 and plus F3 is equals to minus 3. So 1 plus 2, 3, plus into minus, minus and 3. So capital F is equals to 3 minus 3, 0. That means what? There is no net force acting on this body. Isn't it? Why it is not acting, sir? Because you know the applied force and the opposing forces are same. In the last class also I have given the same example. See, if the two persons are pushing the same body with same force but in opposite direction, then what happens to the body? The body will be at constant position. That means it won't move because the net force will become 0. Is it okay? So that's all for today's class in this video. In my next video I will explain you some more important topics. But meanwhile you practice this problem and go through with the textbook. Okay, you have online textbook. So from that you have 3 to 4 examples are there. So solve those examples and practice, post it in the group. Thank you.